Okay, really delighted to meet you all, and Happy New Year. Hope this will turn out to be a wonderful year for all of you. So this is a course to be taken by both third year students and fourth year students, right? Can all the third year students raise your hands? Okay. My eyesight is not very good, so I'm going to ask the fourth years also. Fourth years? Yeah, thanks. Thank you. So this course is considered very important by the department. That is why it said that it will continue as it is for the third years. Even though many courses got changed, merged, and so on, this course will remain more or less the same, except for one small change, which I will point out as we go along. It is also the culmination course. That means you learn a lot of things in the curriculum, and then the proof of the pudding is in building a plant, which is what you're going to do in this course, right? As a matter of fact, we asked all of you whether you would like to work on any specific chemical. In the fourth year batch, there were 4 groups that said that they wanted to work on a chemical of their choice. Okay, we assigned. The reason being that we had our alum, Pradeep Jaipuria. I think he graduated in 73, if I'm not mistaken, 72 or 73. He wanted to work on a particular chemical in a similar course. And he took the head's permission. He worked on it. Afterwards, he went on to establish the same plant. And he is a successful entrepreneur. As a matter of fact, he has set up an award for this course for the project that does well. So I assume that we will do that one for fourth years and one for third years. And I strongly believe, in fact, many of my colleagues share this, that it is possible to have some entrepreneurs out of you who will go into the core sector. I'm sure that there will be some of you who will have some IT, internet, and so on and so forth. But it is the core sector in which you will be the most competent person compared to possibly anybody else. Okay, and we believe that such a thing will happen, and this course could be the first step in that direction. And in case any of you would want to do that, the department will be more than happy to support all of you. So the way we are going to do that is, this lecture is, I'm going to give an overview of how this course will be run. Then we have Professor Sanjay Mahajani. He will give a short presentation. And we have Professor Rahul Nabar. You all know him. He teaches the fine chemicals course. How many of you have registered for that course? Okay. Okay, it's better to ask how many of you have not registered. Almost everybody seems to have raised your hand. Okay. So he's our star batsman. He is going to do it afterwards. And then Professor Yogendra Shastri will come and talk. He will talk about sustainability and carbon footprint and some of these things. Okay. So these are some of the references that will be used. Okay, and here is a Texas A&M University. They have given a link, so we thought that many of the references in that will be useful. So I have given the link for that also. I want to show you the weekly schedule. It's a very, very tight course. It is not possible to postpone any lecture. It is not possible to cancel any lecture because we cannot make up for that. Okay. So there is a weekly schedule which I will show. We will put the weekly schedule also on the Moodle. So we have shown CL331 and CL452 separately in case there are going to be any differences because of your previous courses and things like that. But let me open this CL452 weekly schedule. So we have the first week, and the date is given, 14th January, 17th January. So we will have this class on Tuesdays and Fridays, Tuesday afternoon and Friday afternoon. And in every class, so whatever I'm saying is going to be applicable to the third years as well as the fourth years. The class will be divided into two halves. One half will do the work and the other half will make the presentation. So in other words, so you will have, Priyam, what are these called? A, B? You will have two divisions, A and B, in each class. So division A will make presentation and division B will do the work for their presentation on the next class, right? That division B who does the work, they are not presenting, they will be here. So in this class, this is the classroom for both third years and the fourth years who are doing the actual work, okay, who are not presenting. They will come here and we will have two TAs here. And those who are presenting will be divided into three panels. There are going to be two faculty members in charge of each of the panels. And so we have some of the faculty members here. And as you can see, the department has assigned 12 faculty members to teach this course. 6 for 331 and 6 for 452. Each will have 3 panels, okay? So it's an important course. That's why the department said that they will assign 12 faculty members to teach this course. Now, so we'll have, so this is written as Division A and Division B. Division A will start presenting 14th January and then 17th January, Division B will make presentation. And what they are supposed to do is given here, explained as the task, literature review and background work, then detailed flow sheet development. Here I call it as mass balance. Mass balance means you will have to say something like, I have this column, I expect this kind of split. Or I have the reactor, I expect this amount of conversion. So you will put those numbers, and based on that, you will be able to do the mass balance. It is not based on detailed calculation, rather it is not based on a simulator work. Simulator is going to come later, right? You will have to say that this is what I want from this, or this is what I see in the patent. In the patent, they say that I will get a 90-10 split. So you put that. So you'll be able to do a mass balance using that information, right? Similarly for reactor, separator, so on and so forth, mixer, whatever you have, right? So you have to do that kind of mass balance here. After that comes steady state flow sheet simulation. The fourth year students have already been exposed to DWSim, so you may find it convenient to use DWSim. If some of you want to use some other simulator for whatever reason, it's okay. For example, you might say thermodynamics is better, or that property is present in Aspen Plus but not in DWSim. I'm going to use some other simulator, that is okay. Or some of you might say that I have a difficulty in convergence, maybe Aspen Plus has a better model. People have reported that there is a problem. Of course, it is possible that if you don't try hard enough, it may not converge, in which case it will be a waste of time to shift to a new simulator. You would rather make sure you put in the effort in the old simulator and make it work, right? The third year students have not had a course in DWSim, and the department said that let them learn DWSim as a part of this course. All right? Otherwise, you won't have fourth year free to do whatever you want, right? That's what you wanted, right? We wanted to release the free time for you. So what we are going to do is, by the way, DWSIM learning is extremely simple and you can learn without any problem. And for you, for the CL331 students, on Friday, in this very classroom, Priyam and his team will conduct a workshop on DWSIM. Okay? So all of you come over, and those of you, even 452 students, in case anybody wants to be here, you're welcome. DWSIM will be covered, and we have learning material through what is known as spoken tutorial, which is created for self-learning, and so you can figure it out yourself, right? It's not a, it's very easy. I know that you can figure out all new things, and DWSIM is no exception, right? So in this, one of the things that you would also do in this week, in week 4, week 4, of course, the dates are given here. One of the things that you have to do is, you have to compare the results obtained from mass balance and simulation and justify the difference. Remember, you did a linear, we called it linear mass balance here, right? Perform linear mass balance. So you got some values. You said, I want this split, I want this conversion, I want this purity. Accordingly, you came up with a mass balance. Okay, how to arrive at that? How did you get that? You got it from a reference, literature, journal article, patent, or whatever it is. So you put those numbers, right? So without asking, without doing a detailed study of how you are going to get it. Okay. So you have the mass balance and energy balance you don't do, only mass balance. Okay. But when you go to the steady state flow sheet simulation, using whatever simulator you are going to use, you will do the simulation and then you will compare the results obtained from mass balance and simulation, and you have to justify the difference. Okay. So in other words, the steady state simulation, the flow sheet based simulation is done to arrive at the splits, convergence, conversion, so on and so forth, right? That's what this is for. Then after that, you will do parametric study of operating parameters. So in this, can you suggest some parameters that you would want to study? Can you think of any parameters whose sensitivity you would want to find? Name some parameters. Anyone? A reactor, for example. Okay, so you can think of it as residence time, for example, right? You can think of it as a temperature, feed temperature, right? You can think of as maybe whether it is adiabatic or operating temperature. One is, of course, feed temperature, the operating temperature, so on and so forth. You may want to perturb some of these things so that it will tell you for in some range there is no change at all, then it allows you to choose a particular value that makes economical sense or makes sense from safety point of view and so on, right? What about a distillation column? What do you think? Reboiler duty, okay? So reboiler duty means you may say, I want to change the purity, right? In some cases, it may be possible. Some cases, if it allows you, if you can operate in a band, then it is okay. You can do that. Okay, anything else? This is what I wanted to hear. So reflux ratio is, supposing you say that I'm going to do 10 times the minimum reflux ratio. Will the purity get better? It might, right? So is there a consequence? If you use a very large reflex ratio, what will happen? Less of the product. Reboiler duty, what did that person say? What will happen to reboiler duty? Reboiler duty will also increase because you have to reflux. You are sending a lot of things below and then you have to heat it. Right? So you may say, I'm going to get 0.1% improvement, but your energy cost is going to shoot up. So please do not, so which means you actually don't have any freedom in working with reflux ratio most of the time. The simulator will give you, simulator will say, I can do a sensitivity study of the distillation column using reflux ratio, but please don't do that. Because if you do that, it will say put very large reflux ratio because you will get better purity. But you will go bankrupt, right? You'll go bankrupt. Because truly speaking, if you want to see the effect, you should include the energy cost also. But then you may not have done the costing by that time. So it's not possible to do that. So it is better to stay away from the reflux ratio. Please, all of you remember, if anybody perturbs the reflux ratio, I'm going to flunk you. Okay? Anybody comes up with a reflux ratio and say, I'm going to use 10 times the reflux ratio and do such meaningless simulation studies, you will get at least 1 grade less, if not getting flunked. Is that okay? Is that clear? Why you should not use reflux ratio as a sensitivity, as a parameter for sensitivity studies. Okay, so here you see, look at line number 10. It says evaluation stage 1. Here you will submit a report. You have to submit a report. Until this time, so this says on 28th January and 31st January. On that day, you will submit a report and there will also be a presentation. Okay? And then you have steady state flow sheet simulation, parametric study of operating parameters, and then in this week, stage 2 report will be submitted, and there is nothing additional here, but you will complete the specific tasks given by the faculty panel. Faculty panel will say do this, do that, or some other things you may not have done this week is given to catch up, right? And after 21st February, you are going to come back only on 7th of March. Why is that? Mid-semester exam. And in fact, the mid-semester exam will start immediately, right? In fact, whole of the next week. We could have started on the next Monday itself, but then the students will come and say, I didn't have time to prepare, right? So we are giving the Monday off so that you have time to prepare. So the next presentation will be on 7th March, Friday. Is that clear? Then it shifts. Then Division B comes first and Division A comes next. Okay. Why is that? Because in the past, Division B students have complained. Division A students have complained. I have an disadvantage because I am presenting first. So we are going to make them present second after mid-semester. Is that okay? So equipment sizing of all equipment, economics. Professor Sanjay Mahajani has quite a few things to talk about economics. Detailed design of one equipment that you have to do, and then the date is given, evaluation stage 3. Then we have environmental impact assessment, report submission and final presentation, and then we have final evaluation. So your classes will end on 11th April. What we might do, we did this last year, we might do it this year also. We might select 1 or 2 groups, maybe 2 groups from each panel, and we will forward them to the industry assessment and select the top 2. Last year, we actually had the industry people coming and looking at all 6. Remember, we are going to select best 2 from each of the 3 panels, and they will go through it and select the top 2. Last year, we had a presentation by these 6 groups to the industry experts. I'm not sure whether we are going to do it this time or not, because we have to do it for 2 years. And I don't know whether we have slots. Okay? But we will play it by the year. We might still do that. But assessment by the industry, that we will try to do. And that is where any question on this? Whatever we discussed just now? Okay. So that was weekly schedule. Grading pattern. Okay, let me show that. So here are the breakup of marks. Weekly tasks 30%. Okay, weekly tasks means whatever you are going to present. And then evaluation. So this means this is only for presentation, right, Priyam? Weekly tasks. Evaluation stage 1, 10%. This is for the report? Report and Viva. Okay. So evaluation stage 1, 2, 3 and 4. 4 we call it final evaluation. Those marks are separate. Both presentation and Viva. Both presentation and the report. Okay. By the way, presentation means it is Viva also, because we will ask you questions, and we can have discussion on how the presentation will be made and how we will assess you and so on. We can talk about it later. But the weeks in which you are going to submit the reports will be referred to as evaluation stage 1, 2, 3 and final evaluation stage. Okay. Those together will carry 70% marks. All other weeks' presentations will carry 30%. Is that okay? And the evaluation stage breakup, Viva will carry 60% and report will carry 40%. The report will have common mark for everybody, but Viva will have different marks depending on how you present, whether you have done the work, not done the work, okay, whether you are able to answer the questions and so on and so forth. Based on that, we will give 60% of this, which means evaluation stage 1, 6 marks will be for Viva, 4 marks will be for the report. Is that okay? 60% of this 10%. Report will be 40% of this 10%. Stage 2 and 3, it will be 60% of 15% and so on. By the way, all the files, everything that I'm showing will be uploaded on Moodle. So in case you missed out something, don't worry, it will be there. So during the weekly tasks, a soft copy of the presentation should be uploaded onto Moodle by 11 a.m. on the day of the presentation. Okay? All the presentation should be uploaded onto Moodle by 11 a.m. onto the Moodle. And that's what will be used. And if there is any late this thing, there will be a penalty, and it will be that presentation which you will use for presenting. You cannot say, I made a mistake, I have a corrected one, will not permit you. You better put it by 11 a.m. and use that. So in other words, you do everything ahead of time. We don't have time to do all these things. This course has to go as a clockwork. Okay? We will do a plagiarism check on every report, and institute's norms will be followed in case of any plagiarism. Extremely important, extremely important. Okay? Heads of many important people have rolled because they plagiarized or there was a suggestion. So we are no exception, right? So we will use the plagiarism check software that IIT has enabled. The plagiarism index has to be less than 20%. If it exceeds 20% by X%, there will be a penalty of 5X% up to 40% similarity. Okay? So, in other words, if there is an index of 25%, that extra 5% times 5, so 25% penalty will be applied. Okay? Beyond 40% similarity, the report will not even be accepted. It will be rejected. Okay? Please take the plagiarism extremely seriously. Next one. One of the things, people have the habit of copying all kinds of figures, unnecessary things. You do a literature search, some figure came, beautiful looking figure, copy paste it. So up to 45 figures can be copied from other sources, provided that the source is acknowledged. For any figure beyond this, there will be a penalty of 5% for each figure. We don't want you to do that. You redraw it. Okay? Don't put unnecessary figures. Don't clutter the thing. Don't make it look jazzy with lots of beautiful looking color pictures. We are going to penalize if you do it, if you overdo it. We have TAs. Every panel will have one TA. There are 6 panels for 2 courses. And there will be 2 TAs here. Okay? They will also be available for any makeup session and so on. As I already told you, there will be a DWSIM workshop for CL331 on Friday, 10th January 2025 in this hall. Okay? Report writing, Professor Sandeep Roy suggested that can we use Google Doc? So we said that it will be okay. We will use Google Doc, create a folder for every group and separate PDF for each stage, so that we know what you submitted, we know what we looked at in the previous one. And of course, you have to submit 2 physical copies of the report. By the way, this report submission comes 4 times. Okay? And there is only 1 copy. You don't have to have, there might be 6 people in a group. You don't have to submit 6 copies. Only 1 copy, actually 2 copies are required, 1 for each examiner. There are 2 examiners in each panel, so you have to submit. But the Google Doc per se will be only 1. It will evolve. Okay? So that will allow that the same Google Doc, same report is, you can look at it at various stages. Okay? Is that okay? Are you comfortable using Google Doc for writing the report? Okay, in case somebody doesn't want to do it, you would rather use LaTeX, you're welcome. Okay? Okay, this is an important thing. A few years ago, I think it was 2020, there was a group that found that their chemical was studied in reasonable detail and that a report was already available, some European university. What the group did was they took it and submitted in stages. Okay? But, some of us have also undergone education like you, in institutions like yours, right? So it was a serious problem. We caught and they got FR. Okay? It was a 4th year batch, so it was a problem for them. So, if such a thing happens, what we want you to do is please report it. Please report it so that you don't get into difficulty. It also makes our work totally unpleasant. Do you think we enjoy giving FR? We have sleepless nights if you have to give FR, right? It may be possible that we might allow you to use that. We might say, okay, that chemical is okay, good that somebody has done, let's add to that. It may be possible. That's what I meant by reported. Add to it, for example, you might say that, okay, they have done it in this, through this route, I'm going to take some other route. I'll produce the same chemical. That's fine. And compare, contrast, maybe from, let's say, carbon footprint point of view, it may be a lot better. The new one that you propose, for example, right? You may want to do P&I diagram, for example. You may want to do a detailed design of more units, because we have, in 1 week, you are supposed to do a detailed design of one of the units. Here you might say, do a detailed design of the whole thing, right? Or you might say that let me do a dynamic simulation of a critical unit. There are many possibilities. I'm just giving an example. Or you might say that I don't want to do this chemical, it has already been done, please assign some other chemical. That's also fine. Okay? But please don't do that plagiarism. You'll get into big trouble, big time trouble. Don't want to do that. Is that okay? Another thing you will find, kinetics may not be available. So Professor Sanjay Mahajani will help come up with similar chemicals that have the required property data. Okay? What if thermodynamics are not available? Group contribution method, Professor Sandeep Roy will help. Or other thermodynamics faculty members here will help. Simulation report, simulation support. We have Professor Malik, one of the, I would say, outstanding experts on this topic in the country. He'll be here. He's retired, but I have requested him to be with us on Tuesdays and Fridays. By the way, that's one reason why we kept them together, the third year and fourth year together. I cannot expect Professor Malik to come from Hiranandani, Thane 4 times a week. So now he has to come only twice a week. He'll be here. All your simulation doubts and so on, he'll be here to help. We will have some meetings by industry experts to be organized by, our own people. Professor Rahul Nabar may give some talks. Sanjay Mahajani may give some talks. They may also bring in some experts. Professor Guru's classmates, some of them are entrepreneurs. He may bring some of them. Some of the alumni are extremely passionate about this. In fact, last year we had one, I think 1972 alum. He came and gave a talk, and you should listen to them talk. And you feel as if you'll feel that this is what made their life. Designing the plant. It's incredible. The kind of enthusiasm they can transfer to you. Possibly we should have some of those courses right in the beginning. So that will probably motivate our students. So 4:30 p.m. Wednesday, we will have that. So all your questions, please ask. It will be an optional meeting, and the venue has to be identified. So we'll have to find a classroom where we can do this. So we have some guidelines on how the report should be created and so on, and the presentation. So this is one guideline that we implemented, and it's very good. Whenever you make a presentation, from the second presentation onwards, please point out the suggestions made in the previous presentation. You presented, the examiners told you do this, do this, do this. Make a note of it, and next time when you come, you say these are the suggestions made, and then explain how you attended to them. Do this, as I mentioned earlier, at the beginning of every presentation, and then go on to the new work that you did. Okay? So that will make it very clear. So there is a continuity of what we suggested and what you did. Next, we take up capacity of the plant. So I have suggested choose the capacity of your plant as large as the largest plant anywhere in the world. When you do a literature search, you will find that. except when you have strong arguments against it. It may be carbon footprint, it may be the chemical nobody makes, nobody uses, whatever it is. If you have a strong argument, come up with a new set of capacity, that is okay. But from economics point of view, you should use the largest plant. And then of course, plants, roots, etc. Locate the available capacity for your chemical all over the world. Identify the year of, okay, here you are going to tabulate. You are going to do a literature survey. Say this chemical, this is the capacity, year of commissioning of each plant, what technology is used, tabulate all of these. Okay? This is especially useful for your first week report. Process flow diagram is extremely important. So I'm going to spend some time explaining what is expected of you. This is the most important part of the report every group has to submit. That has all the information about your project. Okay? Creating good PFD is extremely important. This presentation gives a set of rules in the creation of PFD and writing the report. Okay? Use a minimum of 10-point font size so that it is readable. When you give the report, some of you, the PFD will go on becoming bigger and bigger. So how do you accommodate? You put small font. Font 9, font 8, font 6, can't read. Okay, so then how do we accommodate a large PFD? That I will tell you. Split the PFD into parts. Okay, with 10-point minimum font size constraint, the PFD stream data may become large. If large, split the PFD into more than one page so as to include all streams. If possible, split the PFD into logical sections, reaction section, separation section, etc. I'm going to give an example. So here is a sample report submitted by one of your seniors in the year 2020-21. This report, by the way, will be uploaded as a sample report on Moodle. And they got the best project award in that year. So for example, so this is PFD2, part 2. So this is the diagram, PFD. This is the stream data. Similarly, you have PFD part 4. That's what I mean. Don't make the font size small by trying to put the whole thing. Split it, right? Split it into, if possible, split the PFD into logical sections, reaction section, separation section, and so on. If that becomes big, split that also. And do not split the PFDs unnecessarily. Okay? Just because somebody else has 5 PFDs doesn't mean that there are some people who have done that in 2 PFDs. Okay? Without creating too many problems. Try to use the space efficiently. Don't leave a lot of white space. Okay? Try to put them, compact them. Drawing mode, use the portrait or landscape mode as appropriate. You might use a combination of these. What is important is readability of the stream information and listing of all important streams. Okay? Provide space for stream information. Okay? For example, you might say that this is the space available for drawing. PFD, this is the space you saw in Devasmita's report, what they have done. Okay? Providing stream information, variables on rows, streams on columns. Okay, please follow this. These are variable stream numbers 17, 18, 19, 20, because those are the numbers given here, 17, 18 and so on. And then you have the variables, phase, pressure, temperature, composition of the flow rate of each of them. These are all flow rates, by the way. And look at the units. Look at the units. You have to give tons per hour. Don't give kg per second. Okay? Tons, unless you have a specialty chemical, small number, give it in tons so that you have reasonable numbers here. And then you should also give total mass flow rate. Total mass flow rate, so that I can do mass balance just by observation. Just by observation, I can do a mass balance. Total flow rate, and this should be in mass units, not in molar units. Don't do this in molar units. Do it in mass units. You might use molar thing for stoichiometry and things like that, but that's okay. But here, it should be on mass balance, mass rates, mass units, so that just by observation, I'll be able to do the mass balance. I should be able to say this stream is coming in, this stream is going, these streams are going out. Take a calculator, just quickly add these and check what you are doing. Okay? In fact, you may want to do that by yourself. Somebody is doing the mass balance, one of you have 6 people in the team, somebody can quickly do the mass balance. Okay? You can do the overall mass balance, you can also do the component mass balance, where there is only separation. You can quickly do that. Okay? So, please, you will come up with various things. Please don't do that. This is something that we have found to be very useful. Just follow this. So, this is what I have given an example, but then I illustrated with Devasmita's report. Stream units mention the units of all applicable variables, units, tons per hour, degrees Celsius, okay? Give the temperature in degrees Celsius, don't give it in Fahrenheit, don't give it in Rankine, don't give it in Kelvin, okay? Give it in degrees Celsius, okay? Okay, this is something I have already mentioned. Give the time units as hours, not minutes, not seconds. Giving the time units as hours will help you calculate the capacity of the plant for a year. That is capacity of the plant, right? How do you do that? How many working hours in a year, roughly? Anybody told you this? Yeah, somebody said that. So you can take 330 working days, about 24 hours. So if you multiply that, it comes to about 8,000, right? So 8,000 hours. So one can quickly, if you give it in hours, one can find the capacity of the plant just by multiplying by 8,000. So give it in hours, not minutes, not seconds. Okay. Temperature should be in degrees Celsius, not Kelvin, not degree F, not Rankine, and so on. What streams to include? Critical streams that help understand the operating conditions of a plant. For example, outlet stream of a distillation column immediately as they leave, so that I can understand what is the pressure, what is the temperature, and so on. Please put that. It is possible that at the time of when you get it from the patent, some information may not be there. You might leave it out, but you must figure that out and make it available at least subsequently. Because I need to know, we need to know at what temperature this stream is coming out, right? Outlet streams of reactors, outlet streams of special units, and then streams that help do a quick mass balance of every unit by observation. If there are many streams, obvious ones or that can be explained in the report can be left out. For example, supposing only the pressure changes, so you can leave it out, okay? The pressure increases or temperature only increases, it's only a heater, nothing else changes. So some of these can be left out. Why you want to do that? you may want to do that. Otherwise, there might be too many streams. You may want to leave out some of them. But don't leave out the important ones. That's the message. Okay? In general, all streams that matter. Give numbers to PFDs as PFD1, PFD2, etc. Give stream numbers such that we can find out which PFD they belong to. I'll show you that. Here, for example, look at this. Devasmita says, from PFD1, number 17. Right? This is PFD part 2. If you go to PFD1, look at the 17 here. Look at the 17 here. And it goes to PFD2. So you say where this is going and where it is coming from. Okay, here it says from PFD2, stream 26. If you do that, right? If you do that, without this information, PFDs stand isolated and not get connected. They will be hanging loose. You have to tie them. Okay? And then, of course, you can give some naming convention. You can, PFD1 can be numbered as hundreds, 100, 110, 101, whatever, and 200, 210, whatever. You can do it like this. It is okay, whatever convention you use, but please use a consistent notation for the equipment, for the streams, and so on and so forth. Okay? Description of the PFDs in the report. Describe the flow with a special emphasis on the unobvious parts of the PFDs. For example, reasons for a particular choice of equipment or operating conditions. For example, you might say, I use Le Chatelier's principle. Or series of compressors required to achieve high compression ratio. I cannot achieve that ratio in one compressor. So I'm putting 2 of them, 3 of them, whatever, right? I'm using low temperature because I want to prevent decomposition. So that cannot be included in the PFD per se, but in the accompanying report, you can actually write about that. That is how your report should be. Your report should explain the unobvious, not the one that you can easily see in the PFD, and leave out the important ones. Don't do that. And then low concentration required to prevent the poisoning of the catalyst, etc. is applicable. Okay? If you do that, then your description will be very good, and then it will be very easy for us to read the report and understand what you're doing. I would want you to maintain 2 sets of PFDs. The approximate PFD with linear mass balance that you had presented, that is there. Of course, we can always go back and check what you have done. You would have submitted that report. That is there. The other PFD is so you may just want to add a new PFD, and this is a new PFD. You can take it, modify it, but keep a copy of it. This is what I proposed previously. That's linear mass balance. And then this is the new one that is the evolving one, right? The second one. Okay, PFDs with stream data with values. This is the linear mass balance, and this is with a simulator. Okay, this is something I have already mentioned. Compare the results of the above 2 mass balances and enter all results in a table. If the difference is more than 1% for any unit, explain the reason. Okay. The second set of PFD with stream data from converged simulation has to be used in the rest of the course. Okay. Because the first PFD is approximate, gut feeling, based on linear mass balance and so on. That's fine. Later on, you arrived at more concrete, more rigorous. Please use the subsequent one for all future work. So whenever the mass balance can be checked by the observation in the PFD, no need to repeat in the report. It's already there. I can easily check that, right? Some people have the habit of copy pasting the PFD and putting it here. That part of the PFD, putting it, please don't do all that, not required. Okay, it's fine. It makes your report maybe look colorful and maybe increases the number of pages, but not required, right? Do mass balance only when not obvious from PFD. For example, calculate and verify reaction stoichiometry if any. This is something you must do because in your table you are giving it in mass flow, mass units. So here, if you want to validate something, you will have to show it in reactors, for example. And there are many input and output streams. You may want to show that. Do carry out energy balances in the report. This may be done after the simulation. After the simulation, please do energy balance also. This is what I have said. Do not copy paste. We can read from the PFD itself. That's why I keep saying PFD is extremely important. Try to produce a good PFD and we can go look at it. Put all your effort to come up with a nice one. All the information should be there, right? Yeah, it's important to create a good set of PFDs and refer to them repeatedly. So, simulating the flow sheet, you might want to say what simulator you used, whether it is partially converged, fully converged, extent of convergence, any comment regarding how the flow sheet was converged. For some of you, this may not make sense, but do keep this. It will be useful to say what is it you have done. Details of reactors, if possible. What are the different reactors? What reactor did he use? Did he use a conversion reactor? Did he use a rigorous kinetics? So on and so forth. Equilibrium reactor. There are different kinds of reactors you might use. Distillation, shortcut column, rigorous column, ChemSep column. There are different columns that are there in whether it is DWSIM or S1+, you may just want to mention. These are the units, the equipment number, and this is the model. And then absorption, extractive column, and so on. So you might say equipment list, provide summary information of the equipment in a table like this, how many pumps, heat exchanger, compressor, whatever. You don't have to give the cost details here. In fact, one of our previous examiners will say, don't give the cost here. Information on pumps, delta P, head, type, what fluid. Do not provide cost information in the above. It does not make sense to know about the cost of pumps in a plant, for example. What is the total cost of all the pumps in a plant? She says it didn't make sense. It makes more sense to know about the total cost of all the equipment in the section of the plant, say the reaction section. Information on heat exchangers, process fluid, the fluid that is getting heat exchanger fluid, whether it is water in, out, what duty, what material, and so on. Column information, please mention whether the numbering is from the top or from the bottom. Okay, numbered from top, numbered from bottom, right? Then it becomes very easy for the reader to understand what you're doing. Okay, where is the feed stage, okay, and where you might have multiple feeds. So it will be better to say that, okay. Validation of the plant cost. One of the important things is you will calculate the cost of the plant. There is an indirect way, there is a second way to validate it with the cost of a similar plant. Somebody else might have come up with a plant, and in fact we found, interestingly, for many of the plants this exercise could be done. Okay, somebody inaugurated a new plant, it went into production. Okay, by so and so capacity this, so much cost. I mean, these are all rough numbers published in papers. So take that information, apply the scaling factor in estimating the cost. If it is established at some other year, apply the time factor in estimating the cost. If it is in some other country, apply the country conversion factor. So it should be possible to do that and say, this is what is the cost and I have arrived at this cost, right? By doing detailed calculation, saying that I'm using this distillation column, I'm using this reactor, I'm using this pump, the cost is this, detailing the cost of each unit, totaling it, this is the cost, right? And of course, there are other rules, as you would see in the references that I pointed out, operating cost and various other costs, so on. I think we are very close to the end. Do not increase the pages. Do not increase the number of pages unnecessarily. Long report does not mean higher marks. Okay, a sample report I already showed. This is the Devsmita's report. If you click this, it will take you, if you are already logged into Moodle, it will be posted there. Is a link to a report that follows these rules, whatever I mentioned, right? So that is the last slide that I have. So I try to summarize, the conduct of the course. There will be many other things as we go along. It's very difficult to, put all of those in the form of rules and regulations. Although I said that finally your panel examiner's decision is final, okay? Because they might say, I want you to do it in this particular way. So that's perfectly fine, okay? Supposing I had said that use landscape mode for PFD and your panel says no, portrait, absolutely fine. Please do portrait. So I'm going to go by whatever your panel, your examiners tell you. And I believe that it's a very, very exciting course. Okay? Very exciting course. But, it might even be like Dungeons and Dragons, right? I don't know how many of you have played Dungeons and Dragons? Anybody played? Okay, not so bad. You don't get killed here, right? Dungeons and Dragons, I used to get killed so many times, right? But, and by the way, I won it once, right? Only once. Of course, I don't play now. I'm too old to play. But I used to play when I was young. And lot of exciting things, lot of opportunities, right? I think you will like the course. If you like chemical engineering, you will like the course. It is possible, in fact, I would believe that some of you would start liking chemical engineering after doing this course. Okay, it is possible that some of you didn't like chemical engineering so much, but after this course, it's a very, really, really exciting course. Okay, so I'm going to stop here. Thank you.